Hello everyone, welcome back. So today we'll be starting with one very important concept, and that is functions. So in functions we basically will be studying what are the functions and what are different types of functions, and then we'll be covering the arguments, and then we'll understand what is a recursive function, and then one uh, function type is the, or we can call something that is lambda or anonymous function. This is most commonly used one-liner functions. So we'll cover one by one. And before moving further ahead, if you have not been through all the previous lectures, I request you please go and watch all those videos. It will be helpful for you to understand this particular current topic, because we'll be utilizing some of the concepts that have already been covered in the past lectures. So we'll be starting with the functions. What are functions basically? So in a general term, if I ask what is a function, then I can say it is some task that is being performed. And how does it how does it help in programming languages? So what happens is, for making a program, we write certain line of codes, and in that program there are like approximately more than 1,000 lines of code. And in that case, if there is some error, what we have to do is we have to go over complete code and to modify. So to reduce those problems, what we have done is we have divided our code into different sections or different modules or smaller problems. Suppose I am writing a code to make a calculator, and in that I can start writing code for addition, subtraction, multiplication, division, or modulus, percentage, anything, and I am writing all into one single module. Okay, so what happens if there is a single error? The whole program will stop working. But when we are making functions, what happens is each individual module is tackled separately. That is, what does that mean? It means like, if there is an error in one particular module, rest of the modules will keep working. It will not affect. Suppose I have written something wrong, some codes are like some statements I've mentioned wrong, or something I've written in a wrong syntax, or there is some kind of error in some function, and other functions such as subtraction and multiplication and other functions, those are mentioned correctly, then it will work perfectly fine. Just a second. So yeah, so I was saying that if there is something wrong between the sum module function or sum module, then it will not affect any other part of the program. The multiplication, division, and all those things will be working in a better way. It will not affect the whole program. If you are not getting it as of now, don't worry, we'll be covering the calculator program, and then we can understand how exactly this is going to help us. And one another very important use is, sometimes there is a repetition of certain codes, like every time I'm entering a password, I have to go and randomize it, and or I have to verify it with the old given set of passwords. So it's a repetitive task. Okay, so instead of checking again and again, I can make a function that can check the password on our behalf, and it can give us the final result whether it is correct password or wrong password. So we do not need to write the same program, same lines of code that is checking our program, like username and password, again and again. Okay, so we can make a function out of it, so which can like reduce this task of repetition of the codes. Then comes how to write the what is the definite method of writing a function, how, what is the syntax. So we have basically seen one function in previous lectures, but today we'll be covering it in great depth. So to make a function, we use a command that is called as def, and then we write the name of the function. You can write any name of the function, and then inside that there are arguments. These are optional. You can give some arguments or you can skip it. So when I say arguments, it could be like on which, these are the parameters on which your function is going to work. Suppose if okay, we'll cover that with an example so that it's easier for you to understand. Then we have some doc string, and this is optional, but it is good practice to write doc string, because this is basically to tell any other user what this function is means is going to do. What are we doing with this particular function? What is the purpose of making this function? We can write in this doc string. Okay, and then we have some statements or the body of the function, which is basically like what function is doing and how, what different types of calculation it is handling. So all those things comes into the statement part. And one thing that you must take care is that you have to put a double colon here, and then whatever thing you write should be indented. So that is from here to here, this is a part of this function, because every line is indented. So there is indentation, sorry, so it is indented uh, like one tab or two tabs. It's like make a practice of using one tab, but whatever number of tabs you are using or spaces you are using, it should be same for every line. It should not change. So if you are indenting for one tab or one or two spaces, make it same for every line. And I'm sorry, I have like I told in the last class, I have ulcer in my tongue, so you might find my tone a bit confusing. Don't worry with that. I'll try to keep it as clear as possible, but it's not easy. It's hurting me. Okay. So here is a basic function that is called as hello world, and it is giving me some message. So what I'll do is I'll write one particular function. So I'll start with def. So name of the function I'll keep as message or birthday wish. So name of my function is birthday wish. So what I'm going to do is I'll ask the user his or her name, and then I'll print a birthday message. Okay, so we have already seen how to do the formatting. So we'll use dot format, and in this I'm going to give the name. Okay, so this is our function. So our function is ready. Okay, now there is one thing that is optional. So you can return some value from this function. Okay, so I have done some calculation by using this function, and I want to return that result back, so I can use the return command. Otherwise, if you do not want to return anything, you can just remove it. So in this I just want to print a message, and nothing else. Okay, so I'll just run this and it's done. So this is function definition. This is what? This is a function definition. Now I have defined the function. Now I will call it. Okay, when I say call it, that means I am using this function for myself. Okay, give me name, give me a name. So this is what, now I have to call the function. So calling means if I have to call somebody, I'll call them by their name. So the name of my function is birthday wish. So this is calling the function and I am passing an argument into it. So argument or parameter is name. This is my argument. So what this function is going, birthday wish is going to do is it's going to do some task on this variable, that is name. Okay, so this is going to do some task on birthday wish, is going to do something with name, and from here the name is going to come here and it's getting copied in this name. Let's change it to name one. You can keep it same, does not matter. So from name it is going to name one, and name one it is going from here to in this function. So first I have run my function, I have made the function. Now I'm calling it. So I'm it's asking me to give me a function, sorry, give me a name. I'm giving my name, and then this name is going to get copied here and it is giving me that message, happy birthday bridge, wish you a happy life. Just give me 1 second. You try making another function with your name. I'll be back in a minute. So this is one example of making a function called as birthday wish. So you can make your function, and this is how we call a function. So if you want to use a function, you have to call it. So this is one example where I have given one argument. I'll show another function where I'll not be giving any argument or parameter. So def birthday, not birthday wish, I'll make it table. Okay, so what this function is going to do is it's going to print the table of any number. Okay, so what is happening is, let me ask user uh, n is equals to int input. So I'm asking a number inside the function itself, and then for I in range 1 to 11, because I want to print the, okay, and then actually this was the question we did, I gave as an homework yesterday. So I'll write this into this is equals to this. So we have dot format. So first number, that is n, into I is equals to n star I. This is done. So this is our function that is done. Okay, let me run it. Now I'm going to call this function. I just simply have to call like this. And if I run this, you see I'm not passing any value inside this table. It is without any table. Okay, the no argument is being passed. So I run it, and now I'm going to run this. So from here it is going to here, and it is going inside, and it is asking me to input a number. So I'll enter, suppose I enter 4, and you see what I'm going to get is 4 into 1 is equals to 4, and up to 10, that is 40. So this is one example where we have not used any argument. So we have understood both thing, what exactly we are doing here. Okay, one more thing, doc string. So doc string is triple quote. You can do this. Okay, so this is triple quotes. Doc string is basically what kind of what we are doing doing with this function. So printing table of any number. Okay, this is what I'm going to do. And now I run it, and I run it here. I give 4. You see I got the answer same, but this thing is not getting printed. This is just a simple. And if I want to see the doc string, I have to write here, copy it, paste it. Okay, so the name of my function is table dot underscore underscore doc. Now this is going to give us the document that I have written. So doc string that I have written inside the double quote, triple quotes. So this is basically, if somebody wants to know what exactly this table function is made for, so I'll write a document about that. Documentation is done inside this function, so anybody can run it and check it by table name, function name. It's not compulsory, but it's a good way to write what these doc strings inside the functions. Similarly, the return statement is an optional one. Okay, and we'll cover it in this one such example here. Okay, so now we have scope and lifetime of variables. So scope basically means up to what, okay, so if you are living in India, your passport or your Aadhaar card will be valid only in India. Okay, but if you are a frequent traveler, and you have made a passport for USA, so what is going to happen is you are visible to both the countries, that is USA and India also. You can travel to both, so you are global. Okay, but if you just have Aadhaar card, you cannot go to USA with your Aadhaar card. You are local to India. So this area in which you are having access or limits is called as your scope. Okay, and when I say lifetime, it is meaning that if the country India does not exist, you do not exist, because this Aadhaar card is having validity until and unless India is in existence. Okay, similarly, okay, let's understand it by an example here. So I am making a variable, global variable, and I storing some string in that. I am a global variable, and then I'm making a function check lifetime. Inside this I am writing a doc string function to test the time of variables, lifetime of variables. Okay, gv is our, okay, yeah, gv is global variable, and this is equals to global variable. Okay, now I'm defining a function which is going to check life of any variable. So it's good practice to write the docstring. So lifetime of global variable and local variable. This is what we are going to check. Now I'm making a local variable. Local variable means, so this is India. This is our India. And this is whole world, global, that is applicable, that is available to everybody. But local is available only to this function life. So I'm making a local variable LV and I'm giving it some value LV. Okay, so now I'm going to print LV inside the definition, sorry, life function. I'm also going to print GV, that is global variable, inside this function itself. Okay, this is going to be done. Okay, I'll write one more line to check whether sorry, call the function. So this is like, okay, I'll run this, and now I run this. You see, I'm going to get LV and GB because global variable was defined outside of this life function. Still I'm getting it inside. Okay, now let's try to see if we are going to make some changes. I'm going to print GV here outside of the function, and also it is defined outside, so it should print because it's a global. Let me run it. So we'll get 2 GB. Yeah, now if I want to print LV here, will it print? I'm using LV variable outside of function life. It is defined inside life, but I'm using it outside of the life. So will it give some value? Let's run it. So it is giving me an error. You see here, it's giving me name LV is not defined because this LV was defined inside this function life. Okay, so that is why we are getting an error. You can put it in all in one single block, and you see I'm getting an error. Now if I comment it, I'll get the global variable but not the local variable. So the life of local variable is inside that function. As soon as the function is over, the life of that local variable is finished. Whereas the global variable will be available for all the time until and unless the program is not closed. So if the global variable, its life is same as the life of program, whereas the life of a local variable is the life of a function in which it is defined. It is having the same life as that block in which it is defined. Okay, so this was example. So now I have to do a program to find the factorial. Let's do something, not factorial because we did it yesterday. Let's check whether a number is prime or not. So my program will be def prime, and I'm going to ask user a number. So please give me a number and I'll tell you whether it is prime or not. Okay, prime detection of any number. So this program is gonna detect whether a number entered by user is prime or not. So to check that, how to check whether a number is prime or not? When a number is divisible by 1 or itself, then it is a prime number. Okay, and yesterday while doing the program for factors, we understood that any number is divisible by all the numbers from 1 to half of that number. So suppose I'm checking for 70. So any number that is a factor of 70 will lie between 1 to half of 70, that is 35. Okay, above 35 any number will not divide 70. So in case of prime, if we divide any number from 2 to half of that number, we'll not find any number dividing that particular number. What I mean to say is, suppose we are checking for 13. So 13 half is approximately 6.5, so we'll take it 6. So if we divide it from, because if we are not taking 1, because any number is divisible by 1. So if you start dividing by 2, 2, 3, 4, 5, 6, if any of these 5 numbers divides 13, then it is not a prime. But if it is not divided, then it is a prime. Okay. So if, okay, I'm going to count like how many times a number is getting divided. If it is getting divided, then it is not a prime. So I'm making a flag, a variable flag, and its value is 0. Okay. Now if while n, okay, I'll use for loop. I'll not use I in range. I will divide it from 1 to half of that number, or 2 plus 1. So this is plus 1 because range is excluding the last number. Okay, so I'll be dividing any number to which I have to check whether it is prime or not, from 1 to half of that number. Now we know it will always get divided by 1, so I'm counting one time. As soon as it is divisible, our flag will change to 1, then 2. It will keep counting. Okay. Now if our number num is getting divided by I, and this is equals to 0, if it is dividing, what I'm going to do is flag is equals to flag plus 1. If it is getting divided, please add 1 to it. Okay. Else I don't think we need else, we can skip it. Now outside of the for block, it has why outside of the for block, because it has run that many times and the checking of division is done. Now we have to check whether our flag is equals to 1, 0 or anything else. So if it is 0, means there is something wrong, because at least it should get divided by 1. Okay. If it is not getting divided by 1, it is wrong. And one more thing, if the number entered is 0, we'll say if number is equals to 0 or number is equals to 1, then we will say, sorry, print this is neither prime, this is not a prime, let's put it this way, this is not a prime number. Okay, 0 is a whole number and 1 is a not a prime number, it's a how to say, 1 is not a prime number. Okay, otherwise if this is not the case, else, and this all should come inside this, else. Okay. So now what's happening is I'm going to check if flag value has this is equals to 1, that is only one number has divided, then print prime else print not prime. Okay, this is done. I'll run my function. Okay, what's the error? Okay, it should be in small letters. Now I'm calling the function prime and I'm passing, first let's check with 0, and the answer is this is not a prime number. Then let's enter 1. So this is not a prime because at first this is running. Okay, now let's check with 2. Okay, why are we getting error is because, okay, just a second, float object. Okay, so this is getting here error int. I'm converting it to integer. So we are getting prime. Let's check with 3. Okay, let's check with 13. What are we getting it? It's prime. Now let's check 18. Not prime. Okay, this is perfectly fine. So I suppose you understood it here. We have checked, we have made a function prime, we passed a number, and now prime detection, we have put a doc string out of it. How to check the doc string? Print the name of the function prime dot underscore underscore doc doc underscore underscore, and you run it. Okay, you have put multiple here. 2 here and 2 here. Prime detection of a number. Yeah. So if it is 0 or 1, then print this is not a prime, else otherwise do these all things. So I'm making a flag, a variable that is going to count. Okay, you can check here what is the value of flag. Okay, and how to, okay, let's print it here. It will tell exactly how many times this is divided. Okay, now let's run it. So 18 is divided 5 times, from 1, then 2, then 3, then not 4, not 5, then 6, then not 7. Means after 6 we have 7, nothing. 8, no. 9, yes. So 1, 2, 3, 6 and 9. Okay, so flag was 0 at first. That's why getting 5. Okay, there is something I'm missing. Okay, we can come back to it later and decode what exactly is working. It should be 6 here. We are getting just 5 here. So it is divided by 1. Okay, it's not taking 9. It's not taking 9. It is dividing up to, so 18 divided by 2 is 9 plus 1, 10. It is taking 9 also, right? So it should technically divide by 1. It should come 1, then 2, then 3, 5, 6, then 6. Yeah, it's fine. Yeah, it's fine. It's correct. 5. I was counting wrong. Yeah. Okay. Okay. Now we have next topic as the types of function. There are two types of function. First is built-in functions. There are certain function that is already defined by Python, which we can use directly. And then comes user-defined function. User-defined functions are the function which are means made as per the user's requirement. Like we did here, we made a function called as prime because we needed to calculate the prime of any number. So this is user defined function. Okay, and if you remember yesterday about the maths and apps, these are inbuilt function. Python has already made these functions. Okay, so absolute abs, this gives the positive part of any number. Means if you give any negative number, it will convert it into positive number. So our number is minus 100. If we put abs before this number and pass our number as an argument to this abs function, we are going to get a positive integer. What happens with a negative? We know it. What will happen if we put here positive? Nothing, because it is converting everything to positive. Whichever thing is already positive, nothing is going to happen it to, right? So I'm just going to change it to negative and I'm getting positive value. Similarly, we have an all function. This is going to check whether we have any zero or none value. If it is there, it is going to check complete list or complete data collection which we have. And if there is no zero or none, it is going to give us true. Otherwise it will give us false. So here you see I have a set, and you remember we cannot have duplicates in sets. So, and we write it with the curly brackets. So here we have four values 10, 20, 30 and 40. These are unordered. Set is unordered, that is at 0th position we cannot say which element is there. We can see 10 is there, but in reality 10 is not at 0th position. So we pass this to this set. Is this set is passed as an argument to a function called as all. Now this will give us true if there are no zeros here in my set. If I run, you see I am getting true. But if I replace one of the numbers with a zero and I check it, I get false. You remember yesterday we did same thing. If we write -1, we'll get true because -1 is not false. If it is 0 or none, in that case only we are going to get false. Okay, so in the next one we have a list, an empty list. So how to make an empty list? You just put a square bracket and you will have your empty list. Okay, so the name of my list is empty list. So I'm just putting one simple bracket and no elements inside it. So there are no elements, and we also do not have zeros here. So that is why it is giving us true. An empty list is going to give us true. But if we have a value, that is because you remember we can keep uh, different data types inside a list. So I'm keeping three variables. One is 2, then 1, and 1 is false. So this is going to give us false, because false is basically uh, telling that there are something that is 0 or none. Okay, in if we have 0 and none, it in boolean form it is false. So we are replacing it with false itself directly with the false. So definitely it is going to give us false. What will happen if I put it in double quotes? Will it give us some same result? Now you see it is going to give us true because that was a keyword. Okay, this was a keyword. But if you put it in double quotes, it will become an element and a string. Okay, in that case it is not going to give us false. It is going to give us some other value that is true. So if I remove the double quotes, you are getting false. Similarly, we have dir, that is for directives. So uh, if you use, see, this is a list, okay, what different functions, what different things I can perform on this list. If you want to get all those attributes that are valid over this particular iterative, so I'll just pass it into this function dir, and then I'm passing my list. So these all things are applicable on this. So we'll be covering this append, clear, copy, count, extend, index, insert, pop, remove, reverse, and sort. Rest you can ignore, but these are important ones. So we'll be covering it in later stage when we'll cover list in more detail. Similarly, we have a few more. Div mod is a function that is going to give us quotient and remainder. So you see 9 comma 2. So div mod function is going to first give us how many times was means the quotient, that is 4 times, and then remainder. Okay, div mod is short form of division and modulus. Okay, so enumerate is basically used to change the index number. In like reality, we know by default it's 0th position, then we have first position. Here the index is second position, and here the index is third position. But if you put enumerate and to which you want to change the index for, and what is the starting of your index. So once I do like this, what is going to happen is, so the first element was earlier stored at 0th position. Now computer will change that in its memory, that okay, it's not 0th position, it's actually 10th position. Then 2 is stored at 11th, and 3 is stored at 12th, and 4 is stored at 13th. Okay, so you pass here from where is what is the starting point of your index. So that is one such. And similarly, we have filter, and we have seen is instance of in the first class, where we checked what class it is. So this is a set and my set, and I'm checking whether my set, whatever this variable we have made, belongs to a class of set. Is instantiation or making object, we checked it in the first class where we learned about class and objects. So we are checking whether this particular variable is an object of this class. Okay, if it is true, it will give us some boolean value. So this is a set. Okay, and this is a dictionary. I'm going to check whether it is a dictionary. Okay, it is going to give true. If I write here set, it is going to give us false, because my this is what we are making a dictionary here, so it will not give us true value, this is going to give us false. But if I write here dict, that is a dictionary short form, it is going to give us true. We have very important function that is most widely used is map. So what it is going to do is, okay, before doing that, we understand the syntax. In map, we write first the function which is to be applied, okay, and then on which it is to be applied. Okay, this is going to map these elements, that list of inputs, with this particular function. Suppose I have a number set list here, numbers, okay, and there is a function called as half of the number. I have made this function. In this, you pass a number, and it is going to give us return it. Okay, here it is the example of return. It is going to return half of the number, num divided by 2. Okay, so what I am going to do is, we can pass this numbers as an argument to this half of the number function. Okay, or we can put map, then name of the function half of the number, and then passing all those numbers to, okay, then mapping these numbers with this function is the same as passing. Okay, let me write it in this way. This is same as writing half, ignore the cases. Okay, let me write the cases as well. Half the number, and then numbers. This is same as writing in this form. Okay, and mapping each element with this function. This is way of mapping. And then we are converting it to list. List is another function, inbuilt function, which is going to convert any numbers into a list format. And after converting it into list, I'm naming that list as half. So you see here is our output printing the halves. You can see the bracket here, square bracket, that is it is converted to a list. Similarly, we have reduce and many more functions are there. So I'll not be covering everything. You can just always explore in Python. Then we have user defined function. User defined function is based on the your requirement. Okay, if I have some uh, task to do, I can make my own function based on my requirement. Okay, so let's make a simple calculator function. So name of my function is calci. It is going to ask me the numbers. Okay, I'll ask two numbers, a and b, and let's ask some choice. Okay, n1, n2, and okay, let it be choice. I'm asking the user to enter the choice. Okay, let's make not take it choice. Let's make different first functions of sum. So this is going to add two numbers, a plus, sorry, a comma b. We are going to get two numbers and then return sum is a plus b. Then we have another function called as product, prod, and it is going to multiply two numbers. Then I'm going to return product is comma a star b. Similarly, I can write another function also, but I'll stop doing that. I'll make a function called as choice. That function is going to map choice. Okay, if choice is equals to 1, if choice is equals to 1, okay, I'll call the sum function. And I'll give it two variables, n1 and n2. Okay, similarly, if choice is equals to 2, prod n1 comma n2. If the choice is 2, I'm going to print the else. I'm going to give a message, print wrong choice. So that's done. I will make two variables, n1 comma n2, and this is equals to integer type. Ask user to input, enter two numbers. Okay, then I'll ask choice ch is equals to int input enter 1 for sum, sorry, for sum, 2 for product. Okay, Now I'll call the function choice. Okay, here choice of num, choice of num. I'll call the function choice of num, and I'll send my ch here. Okay, let's run it and see what is the error first. Okay, no error, it ran successfully. Enter two numbers, so I have 2 space 3, enter. Okay, let's rerun. 2 3. Okay, sorry. I can ask it in a different format also, but let's keep it this way. Okay, so 2 3. Okay, I'll enter 1 first and let's see what's happening. Okay, I have okay, I have returned it, but I'm not using it here, right? I'm going to print it here. It's returning the value, but it's not printing here. Print it. Okay, let's run it again. So enter first number 2, enter second number 3, enter the choice, let's put it 1, and let me give you the sum of it. The sum is 5. This is our answer. So it is giving sum is from here, and then a plus b is getting printed. Sum is okay, done. So this is our calculator. Now let me try with something else. Oh, sorry. Uh, let me enter some other value. 3 6. Oh, sorry. What I'm doing. Okay, 3 enter 4 and the choice. Let me enter 8. Wrong choice. Perfect. It's working fine. So we know that whatever thing we pass into a function is called as argument of that function. Okay. So now let's see something else. Okay, yeah. So anything that is passed into a function is argument. Now we'll see recursive function. A recursive function is a function that calls itself again and again. You see, uh, this is very basic example, and trust me, this is not that widely used. It's a complicated form. So a function calling it yours, like function calling itself again. So here is a function called as factorial. This is a very common example of recursion. So return 1 if num is equals to 1, else num into factorial num minus 1. So number into, again I'm calling the same function, and now I'm passing 1 less than that number. So suppose it was 5. So if it is 1, you are entering number as 1, so it is returning as 1. Otherwise, suppose if you are entering 5, so 5 into factorial, and I'm passing 4. So if you pass 4, it is going to come here 4, then it is going to multiply 5 into 4, that is 20, and it will keep until it is 1. Okay, and that way you get the answer. Similarly, you can try some other things like Fibonacci series here. Okay. And now we have a lambda function. So these are basically will be used um, or you can say these are the one-liner functions, and you can see on internet many examples in which map function and filter function will be used with lambda functions. So here is a simple example defining a function called a square that is going to find the square of a number. So I'm passing 10 as an argument. It is going here and it is making double of that number, so a square of that number. So if I have to write this particular function in form of lambda, I'll write lambda. Okay, then I'm going to write x. X is basically, it is same as here. Okay, on which this function is going to get applied. So it is going to get applied on x, and then colon, and then what this function is doing. So it is here. Okay, let me give you another example. If I'm making a function of sum, so sum is basically equals to lambda. I'm going to apply it on uh, two variables, let's say a comma b, and this is equals to a plus b. Not like this, sorry. Let me make it even. Only one variable I can give, right? So this is x. So what I'm going to do is check if x modulus 2 is equals to 0. If it is happening, if this is happening, what I'm going to do is I'm going to get this number is equals to even. So I'm going to put the name one variable, and I'm calling this function, this variable even. This is acting as a function, and I'm passing the value of x. Suppose we pass 4, and then we run it, we get true. If you want to print it, you can print it. So this is basically checking whether it is true or false, like. So that's why we are getting a boolean answer. And here also I'm passing my list here. Okay, and using the filter command, filter is basically going to apply this function, or you can use map function here. I'm going to apply on this, and it is going to filter whatever thing is going to give you true, it is going to get printed here. So I'm not equals to 0, that is odd, so it is going to pass one by one element to this function, and if it is not equals to 0, then the value will be true as you see in here, and if it is true, it is filtering it out. So 1, it is filtered out, 3, it is filtered out, 5, it has filtered out. Similarly, map function, I'm mapping my list, this is this variable with this particular function. So this function is going to make the square of each element. So map this variable with this function. So this is a two basic use where you can see filter and map has been used. You can also try it with the reduce function, and I think that's all for today in this particular class. And I was thinking of adding one example of a function where we can program in a way that we can use a function to make you understand how we can program for username and password one, but I think we can cover it later. So idea is to define a function that asks the user to input some username and password, and then second function is to check whether it is correct or not. So make a function as call it like username password, and ask the user to enter the username and password. And second, the check function, you can, okay, so in this what you have to take care is that you have to make a global variable, because if you do not make a global variable, what is going to happen is the value in the first function, whatever the variable you have made in the first function, is not going to stay alive as soon as that function ends. So you have to make global variables, make it a username as a global variable and a password as second global variable, and then you can go and check it in the second one. Try it. If it is working for you, it's good. If it is not, just ping me on WhatsApp and I'll help you with that. And that's all for today. Thank you so much for joining.